Welcome back to our channel. I'm teacher Cedric, and this lesson I'm going to share the solution to our daily practice of counting problems. Now, starting with the first question, the question asks us to find the sum of this series. First of all, we can notice there's a repeating pattern. The sign repeats itself for every 6 terms. Therefore, we can try to group the numbers into a group of 6. But the number 1, 2, and 3 are not enough for us to subtract 4, 5, 6. And the number 7, 8, 9 are also not enough for us to subtract 10, 11, 12. Therefore, it seems like this grouping method does not work. What else we could try? Well, if we cannot start grouping from the start, we could also try to group it from the end. Let me expand this series to get a few more terms. Now, if we grouped the last 6 numbers, we get this, which we can easily calculate and get 9. On top of that, if we group the subsequent 6 numbers, again, we will get 9. So it comes down to how many group of 6 numbers you can find in 2013 numbers. We can simply divide 2013 by 6 and see that there will be 335 groups and 3 remains, which is these 3 numbers here. And we know each group will be 9, and since there are 335 of them, the sum of all these groups would simply be 3015. So finally, if we add 1, 2, 3 to 3015, we get the final answer, 3021. And that solved our first question. Now, the next time you see such question with some repeating patterns, you know we can always try to group the numbers into groups. And if the grouping method does not work from the start, you can always try to from the end. Now, moving on to the second question, it asks us to calculate this huge fraction. It may seem a little bit terrifying at first. However, we notice the numerator and the denominator are actually quite similar. Let me rearrange the denominator to make it clear. Now we can see that the first 2 numbers of each term are the same, except the third numbers. And we know if the numerator and the denominator of a fraction are the same, they will simply cancel each other. So, what we could do to make the numerator and the denominator the same? Let us focus on the number 10 and 4. We know 10 times 2/5 is 4. Let us keep that in mind. For the number 15 and 6, we say that 15 times 2/5 is also 6. And on top of that, 20 times 2/5 is 8. And the same applies for these 2 terms. Therefore, if we could multiply this fraction with 2/5, the numerator and the denominator would cancel each other exactly and we get 1. However, we cannot simply change the question by multiplying a number. We need to undo it by dividing another 2/5. And we know these 2 terms combined gives us 1. And dividing a fraction is equivalent to multiplying with its inverse. Therefore, we find that the final answer is simply 5/2. Brilliant! We have solved the second question. Now, on to the last question. The question asks us to calculate this series. Now, this series is called a geometric series. That is, the consecutive terms all share the same ratio, and in this case, the ratio is 2. And what's so special about this geometric series? We know for a geometric series, if we multiply the entire series with its ratio, each term would become the term that comes after it. So, for example, if we multiply this series by the ratio 2, the first term would become the second term would become the third term, and so on. Now, we get a bunch of overlapping numbers here. It would be nice if we can subtract them. So how to express this mathematically to make it clear? Well, if we assume the sum of this series as S, what will be the sum of this series? Correct? It will simply be 2S. Now, if we subtract S from 2S, all these overlapping numbers would be gone. And we would be left with 2048, the non-overlapping numbers, subtract 1 over 1024. And that gives us our final answer, 2047 and 1023 over 1024. And we have solved all 3 questions in our daily practice. Now, I hope you learned something in this lesson. And if you haven't joined our daily practice routine, you can simply scan this QR code to reach out to us. I'm Teacher Cedric from Kangaroo Study, and I'll see you soon.